In this video, I'm going to be talking about my Millyard Viper V10 motorcycle that I made in 2009, show you how I made some of the parts and talk about some of its features. And then
Today, we're diving into the extraordinary world of Allen Millyard, a true artisan, often described as a wizard with a hacksaw. Alex, his work truly bridges historical preservation and radical innovation. What initially strikes you about his process?
It's his sheer intuition, Chloe. Millyard's design language isn't about computer-aided design or intricate schematics. It's this almost visceral conversation he has with the metal itself. He transforms what seems impossible into something incredibly functional, all from his suburban garage. His ongoing efforts to bring the ill-fated Norton Nemesis V8 to life are a perfect example of this.
That's a fascinating way to put it, a conversation with metal. You often hear his creations described as having a factory look. How does a custom builder achieve that, especially when he's modifying things so extensively?
It's an obsession of his. He deliberately avoids the typical flashy custom bike aesthetic. Instead, he meticulously recreates the original factory finish. If he's adding cylinders to a Kawasaki, he'll match everything: casting marks, paint color, even bolt styles, so perfectly that his finished V12 or 5-cylinder triple appears as if the factory itself produced it. He often says he wants his bikes to look like the special edition a manufacturer should have made.
So it's not just about adding parts, but about seamlessly integrating them, as if they were always there. This seems to fly in the face of modern engineering, which relies so heavily on digital simulations. Is that why his method is often called hacksaw engineering?
Precisely. In a world where every component is simulated on a screen before a single cut is made, Millyard's process is a glorious act of rebellion. You won't find CAD software or CNC machines in his workshop. His design language is entirely manual, driven by a rare blend of old-school craftsmanship and a level of mental visualization most engineers could only dream of.
That mental visualization must be extraordinary. He's said to have a 3D mind. How does that manifest when he's working on something as complex as an engine block?
It's at the core of his work. While most builders rely on complex blueprints, Allen often works with nothing more than the geometry he holds in his head. He can look at a massive engine block and instantly visualize exactly where a cut needs to be made to add more cylinders, frequently without drawing a single line. If he needs a physical reference, he sketches a rough diagram on scrap cardboard or uses wooden blocks to mock up angles. It's an intuitive approach, treating the engine more like a sculpture than a piece of industrial equipment.
And the fact that he achieves precision with a hacksaw on rare, expensive engine blocks sounds almost impossible to me. How does he maintain that factory-level accuracy with such a manual method?
It's legendary and honestly a bit nerve-wracking to imagine. He saws through crankcases and cylinder heads by hand, relying on his physical feedback rather than a programmed machine. But the results are mind-boggling. Despite the low-tech method, his precision is so high that when he welds pieces back together, internal oil galleries and bolt holes aligned with incredible accuracy. It really underscores that a master's touch can surpass the most expensive machines.
That's truly remarkable. Beyond his precision, you also mention his genius for improvisation, using everyday objects to solve high-level engineering problems. Can you give an example of that found object approach?
He's incredibly resourceful. He's been known to use fake charcoal from a gas fireplace as heat shielding for an exhaust, or raid household items to find the perfect diameter for a spacer. This shed-built philosophy isn't just about saving money. It's a testament that engineering is ultimately about problem-solving with the tools you have. Combined with his hand filing and manual lathe work, his machines become personal, handcrafted legacies.
His creations like the Viper V10 motorcycle or the Flying Millyard are known for their massive scale, yet they maintain a sense of balance and symmetry. How does he manage that proportionality with such enormous components?
There's definitely a more is more philosophy, but it's always carefully balanced. Whether it's building a bike around a Viper car engine or using airplane cylinders, he has a knack for making huge components look proportional. He loves symmetry, often grafting engines at specific angles like his 70-degree V12 to ensure the bike remains balanced and rideable, not just as static sculpture. Also, his designs embrace mechanical transparency, where exposed valve trains and manual adjustments are part of the aesthetic, creating almost a steampunk vibe, where the engineering is the art.
That's a great point about mechanical transparency. It invites the rider into the mechanics rather than hiding them. Let's talk about the Norton Nemesis, which you mentioned earlier. It sounds like a white whale project for British motorcycling. What's Millyard's role in its resurrection?
It absolutely was. The Norton Nemesis was a 1500cc V prototype from the late 1990s, promising 235 horsepower and 225 miles per hour. But the project collapsed. It ended up a non-running museum piece. Commissioned by the National Motorcycle Museum, Millyard has spent the last 2 years forensically rebuilding it. By early 2026, he's in the critical phase. He's diagnosed fundamental flaws like problematic throttle bodies and an obsolete ECU, and has successfully integrated a custom Can-Em's ECU and a Honda CBR 600 butterfly throttle system. His recent live startups prove the V8 engine is viable, moving closer to a planned speed record attempt.
So he's essentially fixing fundamental design flaws from a major manufacturer using his shed-built techniques. That's quite a statement. Can you give us some more examples of his shed-built giants?
Certainly. Take the Millyard Viper V10. Most people see an 8.0-liter Dodge Viper engine and think supercar. Millyard saw a motorcycle backbone. The engine is so massive, he bolted the suspension and steering subframes directly to the engine block itself. It's a 1,300-pound beast that, by all rights, shouldn't be rideable. Yet in 2023, he and Henry Cole set a Guinness World Record for the fastest tandem motorcycle at 183.5 miles per hour. Then there's the Flying Millyard, which is almost steampunk. He sourced 2 cylinders from a 1940s Pratt & Whitney Wasp aircraft engine, hand-carved molds, and cast aluminum crankcases. The resulting 5.0-liter V-twin chuffs rather than screams, and the rider has to manually adjust the ignition and fuel mixture as they ride.
It sounds like each of his projects is an engineering marvel, and the engine graft technique you mentioned earlier, combining multiple factory engines, is particularly striking. How does he ensure these Frankenstein creations are actually functional and road legal?
His V12 behemoth is the pinnacle of his grafting. He joined 2 6-cylinder Kawasaki Z1300 engines at a 70-degree angle to create a symmetrical masterpiece. This involved hand-cutting and rerouting water passages, oil galleries, and even welding 2 heavy-duty timing chains together. What's truly amazing is that these aren't just display pieces. Whether it's a 5-cylinder 2-stroke or a V12 behemoth, his bikes are road legal, fully functional, and finished with such precision they appear to have rolled off a production line in the 1970s. He's a reminder that you don't need a multi-million-dollar factory to build a masterpiece. Sometimes it's just a sharp blade and a lot of patience.
Allen Millyard's approach is a compelling counter-narrative to modern manufacturing, emphasizing intuition, patience, and meticulous craftsmanship over digital reliance. His work on the Norton Nemesis is a powerful redemption story for British engineering, proving that a single individual can outperform entire design bureaus. His legacy inspires us to imagine what's possible with just a sharp blade and an inventive mind. If you found this conversation insightful, consider sharing it with a friend who appreciates ingenuity and craftsmanship.